Hello everyone, welcome back. So in this video, we are going to do the dry run of the Leetcode. I think this is the question number 3480, right? So let's understand. So this is the second part of this video and where we will do the dry run, right? So we have to maximize the subarrays, means we have to find all the count, means we have to maximize the count of, you can say, subarrays after removing the one conflict from the given conflict. Okay. So what we have given, very first we have given n, we have given, as you can see here, n we have given, and this n is from 1 to n we have given, right? And the conflicts we have given, this is the pair, right? So this is a 2D array. So each cell contains a conflict, right? And that conflict we have to remove, right? Many conflict will be there. So one of the conflict we will remove, right? Over the some conflict, given some conflict. So if the two numbers are in a conflict, let's suppose call a and b, so we'll check that they cannot be present in the subarray, right? That we have understood in the part 1. Now what is our goal? Our goal is to find the maximum number of subarrays that can be formed. Let's suppose it will go to 1 to like the to the n. Can we see that? So this will be let's call as a array, right? And we have to find the maximum number of subarray, right, from here, such that no subarray contain the conflicting pairs. Conflicting pairs, if we'll take a and b, so this ab, let's suppose there is a 3 and 2, 3 or 4, 2 or 3, let's say 2 or 3 we can take, right? That we have given the example. So this 2 3 should not be allowed in the subarray. So we have seen there was many subarrays were there, right? Let's suppose 1 2 2 3, right? Like that we have many subarrays was there. So these 2 3, if we are removing this conflict, right, should not be in the subarrays. I hope I understand. So what you have to do means you are allowed to remove one conflict pair from the input conflicts, right? So and so that we can maximize the subarray count. I hope you understand. Means we have to maximize the number of valid subarrays. So this was the question we have given, right? So in this part we will understand the dry run. So let's suppose we have given this n is we have given is nothing but 5. Let me say, and this conflicting we have given, let's suppose call can we take like this? Let's suppose in the array we'll take 1 4, right? Then we'll take 2 5, and then we'll take 3 5, and we take this. So if this is the conflicting pair we have given, and n is given like this, okay? So if we will operate, so we need to create two array having size n plus 1, right? So we need to create the smallest conflict pair with I, and smallest conflict and the second smallest. So this is your this is your nothing but the, let's suppose we call it b mean 1. b mean 1 is nothing but it will store at I, and this will say smallest conflict smallest conflicting pair. We can say smallest conflicting pair with I. I is a index, okay? Similarly we can say b mean 2 means smallest second smallest, right? This is a second smallest, right? Okay, so b mean I is, if you can see this, this is nothing but b mean 1. This is not 1, this is 2. Give me 1 second, guys. So this is what b mean 2, and it is I. So there is two things there that we should understand. First, b mean 1 and b mean 2. Make you understand. So b mean 1 is nothing but the smallest conflicting pair at I, and this is b mean 2 is the smallest, second smallest, right, conflicting pair we have. Okay, so these two array we need to define it. Very first we will define. I hope you understand, right? Why we are doing this? Because these two will store these two stores the two smallest values, let's suppose b. So the b mean 1 at I and b mean 2 at I, these two will store the two smallest values b. Can we say that? Such that b is in the range like this, where ib is a conflict and it should be less than, I should be less than b. I hope understand. Means if we'll take, if there is a pair is there, let's suppose 1 and 4, can we say that? So 1 will be I and b will be 4. Okay, so we will check what is the smallest. Our purpose is to find the two smallest b, right? So that the range between these I and b, because this is a pair, right? This is a pair. So this pair is a conflict which contains I should be less than b. I should be less than b, right? I hope you understand, right? This thing. Then we have to fill these arrays, right? B mean 1 and B mean 2 with the max value, right? Why? Let's suppose, give me 1 second. So let's suppose what I'm trying to say here, once you will fill b1 and b mean and b mean 2, right? Means we'll create, let's suppose how it will work, right? Let's suppose we have a pair and we are getting two pair ab from where? From what is given? Conflicting pair, right? Conflicting pairs. Can we say that? Means we have many conflicting pairs, right? From where we are getting one pair at a time, because this is for loop, so we are iterating over the conflicting pairs, right? This is in. Can we say that? Means for each we are using here. Okay, means for each conflicting pairs we'll get one conflicting pair. So can I say A is what? Mean of A and B. Can we say that? Similarly, can we say that B is max of A and B? If these two things we understand, right, it means we want to here insert into what? B mean 1 or where? Insert into B mean 2. Can we say that? Right? Like this, in this order. So insert into B1 mean B mean 1, or insert into B mean 1 or B mean 2, right? This is mean. Okay, understand? Okay, in this order, right? Means we have to first, what we need to do, we'll get the A and B. This is the mean and max value, A and B, and then we'll insert B mean 1 or B mean 2 at what? At A, right? At A, in order. So let's compute how it works. So as we have understood, right, very first, let's suppose we have given A, we have given, right, and we have given, means we need what? B mean 1 A, right, that I told you, and then B mean 2, we can say 2A. Okay, 2A. Okay, so these things will take. So let's understand visually. Okay, so can I say, if I will write a table, right, and here what we have, let's understand, if A is 1 and B is 4, I'm talking about the very first one, right? So when A is 1, B is 4, means this is the pair we have, right? A and B. What is max? Max will come where? Let's suppose it will come B mean A is it coming 4, right? Right, and here it will take, let's suppose, infinity. Infinite value will be there because we are taking the max value, we are taking my max value. So if I'll take either this or this, right, we'll initialize, if it is mean, we'll get like this or we'll get like this, right? either of these. Can we say that? Similarly, if we'll take this 2 and 5, another pair will take. Means what is the max here? 5 is the max, right? And what is infinite? We'll take this as a infinite, right? Similarly, another pair will take 3, 5. This is what 3, and this is 5. What is the mean? Mean is 5 here. Max is 5 here, and infinite will be this, right? So we'll find the value like this, right? So can we say that after saying that, what is our array? So we'll say B mean 1 will contains what? It will contains first infinity, comma 4. This is the range first we have. No, don't take like that, because this is array, right? So we'll take array like this. So infinity 4, then what we 4, right? For the first case we are getting, then what we are getting, infinity, we can say 5 and infinity. So let's say 5 and infinity. Can we say that? What is one? No, 5. This is 5 also coming 5. This is also coming 5, right? 4, 4, 5, 5, 4, 5, 5. Yeah, 4, 5, 5 is coming, right? And there will become infinity, infinity, right? Similarly, if we'll do mean 2, what is coming? All are coming what? Infinity. We'll take infinity, 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 infinity. Means the max value, integer max value. So this array will be initialized like this. So that is what we are doing at here. I hope you understand, right? Now think what we need to do further, right? Means what we need to do here, we have to traverse I at n to 1. Means we will traverse I from n to 1, and then we'll calculate the subarray. Let's understand how to do that. So in the next step, what we need to do, right? We have to traverse. What we need to do? Traverse right I from n to 1. Can we say that? And then calculate subarray. Can we say that? We have to calculate the subarrays, right? At here. And for that, we'll define these things. Means we try to calculate for each I the number of valid subarrays starting at I, such that conflict is violated. So we will use this IB1 is equal to n, means this is the best index with the mean conflict so far. This is the, can we say that? The best index with mean conflict so far, right? But when we are doing this one, right? What we are trying to do here, as I told you, what is I here? We are trying to calculate each I. For each I, we are trying to calculate what? The number of subarrays, valid subarrays you can say, that start at I. Means at each I, we will find the number of valid subarray, right? And this subarray starts at I, right? And we'll say we'll go to I to J, correct? And for that we need what? AB1 is equal to n, means this is the best index with the mean conflicting so far. And then we'll take what? B2, and this will be what? Infinity. And so we'll take integer dot max value. So this is the second minimum conflict means called upper bound, right? That we have, means IB1 and IB2, and we'll compute the del. I'll show you in the next So we'll create a del count and we'll check how many extra subarrays we could gain by removing a conflict that involves, right? And then we'll loop here and we'll understand. So let's understand here. So what we need to do here, we'll go with the for loop that start at I equal to n. We'll go till the I equal to 1, right? Till we'll go and we'll keep decrementing backward comparatively. Okay, So very first we want to compute what? This del count at I, right? And what is this I? IB1. So at IB1 we'll find two things. We'll check the b math.mean b2. What is b2? This is b2, right? We can find this b2. We'll understand what is b2. And then b mean 2, right? Means this b2 will find, means this is the second minimum conflict, which is upper bound that we will find, right? And we'll keep updating the best index with the mean conflict so far, right, at each time. And then you will find the RDS. I hope you understand, right? Means for each I that we will iterate here, for each I that we are iterating here, right, we have to find this b1 and b2. B2, b mean 1 and b mean 2 will update, right? So b2 is the second minimum conflict that is having upper bound, right? And IB1 that we know, right? So this will contain what? The best index having the minimum conflict, right? So far. So each time we'll check if b mean at means the best index we are providing, that if it is greater than this given index. Okay, if it is greater than, means what? This is the best. What we should do? We should update the second most, right? Means the second minimum conflict upper bound will update, and then we'll update this one. So let's understand by example. What we can do, we are looping what? We are looping from I equal to, let's suppose 5, right? And we'll go till down to 1. And we say that this is upper loop. So if I'll take I here and we'll say 5, 4, 3, 2 and 1. So these are our loop, okay, for the I, for this loop, right? Then we'll have to find what? B mean 1. Can we say that? So let's say B mean 1 at I. Can we say that? Then we'll say IB1, right? This is IB1. Then we have B mean 1 at IB1, right? And then we have to find the mean and the count. Can we say that? So let's suppose, what is this? Let's suppose I'll give this X and this is Y. Okay. So what is this X? Understand, this X I'm taking as a mean of, right? We'll take the mean, or we can say RDS, we can also say, right? We are taking here, right, this value. But so we'll say that rather than saying X, you can say RES. Okay. And then we have the del count that we have to update each time, right? This del count, and this is del count, I'm writing del. Okay. So each time we have to update. So let's suppose when I is what? I is 5. Then this value is what? Infinity, that we have seen. Then IB1 means the, what is the best index with the mean conflict we have till now? That is 5, right? And if we'll find the mean, this what you call B mean IB1. So currently we don't have anything, so we'll say this is infinity, right? And we then we'll find the res. So you know the RES is, you have to do the mean value, right? And you have to do the minus. So mean value of this and this, n plus 1. N plus 1 is what? 6. And this is what we have in, let's suppose this is for now is infinity. Or you can say in the, what you call infinity value we have, right? Integer max value. So which is minimum? Obviously this is minimum. So n plus 1 is what? 6. We can say 6, right? 6. And then we have to, I is what? 5. We start from I is equal to what? 5. So 5, this one will become what? 1. Can we say that? So I will remove from here and we'll say just 1. Are you understanding? 6 minus 5 is 1. Okay. And then del count we are increasing. So you know what this value will give you, right? This will give you n plus 1 we have, and similarly we have what we have is n plus 1. So you know you have calculated this part value from here. So this will give you what? N plus 1 is 6, and this will give you what? You will put all these value, this b value, b2, we have got this b2 value, right? You will get, and this value n plus 1, right? Means total from infinity to infinity, you can say from infinity to infinity will update right here. So we can consider here as a, will getting as a 1, okay, from infinity to infinity. Okay, then when I equal to 4, when I equal to 4, we'll take this as a infinity, then this will become what? 4, right? What is this? 4. And for this b mean at ib1 means the best index, at the best index, it become what? 6 minus 4. 6 minus 4 is get added what? 2 here, and for this it will keep, it will be infinity is itself, right? And so this value will become get updated now is 2. Now at 3, what will happen? We have 5 here, right? Right now we have what? We have 3 value we have. So we'll take the minimum, right? Maximum will take what is coming? 5 will get, right? So 5 minus 3 is what? 2, correct? And then it will update it like again 2. Similarly, we'll have at 2, we'll get, this is 5 and this is 2, right? Now check which is the maximum. This is the maximum, right? 5. 5 minus 2 is 3. So we'll update this as a 3. Now at 1, what we have at 1? So at 1, we will see this value is 4 and this is 1. So which one max? 4 is the max. 4 minus 1 is 3, and this is also 3. I hope you understand, right? So if you will find the RES, result is sum of all, means we will add 1 plus 2 plus 3 plus 3, right? 2 plus 2, 2, and plus 3 plus 3, I think, yeah. Then this 1 plus 2 plus 2 is 5. 5 plus 6 is 11. Total will come 11, right? So like this we will update our value, and we'll say this will become your value. Once you updated the del count, you just need to do what? You need to add the maximum del count after removing one conflict. So you will check the value here, right? You will check the, what is the max count. So if you go through the max value, you are seeing that 3 is coming 2 times, and here we'll get what? This is the 3 will get in the max. So final answer will update here. You know, RES coming what? Is 11. So 11 plus this 3 is 14. So the 14 will be answer for the example. I hope understand. If you have any doubt, let me know in the comment section. So I hope you understand, right? So for, let's suppose for 2 and 5, right? So we assume that we have removed 2 and 5. So now the valid subarray become what? Let me go and remove all of this. Okay, sorry. So we want to remove what? 2 and 5. So what are the valid subarrays will be there, right? We have what? 1, 2, 3, 4, 5. Can we say that? Means if we'll remove 2, 3, the valid subarrays are 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. Then what we can say is 2. The valid subarrays are is 2. Then what we have 2, 3. Then we have 2, 3, and 4, right? And then another will take what? 2, 3, 4, right? Then we can say 2, 3, 4, 5. Then what we have 3. Then we have 3, 4, right? We have 3, 4. Then what will come? 3, 4, 5 will come. 3, 4, 5 will come. And then what we have 4. Then we have 4, 5. And the last one is 5. So these are the valid subarray we have, right? Some of these may be invalid if not handled carefully, right? but you understand what I'm trying to say here. So this is our code that optimize our problem, and it gives you a better understanding. So if we'll talk about the intuition behind this problem, right? What we have done till now means we are building the, what do you call, give me 1 second. Okay, so we are building the maximum number of non-conflict array, and for each I, right, we compute how far it can extend before hitting a conflict. Then we'll simulate one conflict, and we'll find the removal that gives you the maximum gain, right? And then you add the gain to the base count, right? So that's all I have in this video. Let me know in the comment section that you understood or not. It's really little tough question, right? But if you do the dry run by yourself, take a white paper, white note paper, and try to do by yourself, right? You try to visualize first, then you will understand the code. Okay, I'll try to see I'll try to see the comment section, and if I'll find any informative comment, I'll try to come up with the solution that you can put into the comment section. So make sure you try by yourself, give a good try, and let's learn together. Thank you guys. Thank you for watching this video. I'll see you in the next one.